record here. So don't forget, part one of your requirements homework is due tonight. So that is just the FRs and NFRs. And I noticed probably about a third of you have it in, so just make sure that you turn that in because, um, yeah, make sure you get your points. Um, yeah, and then we'll go through the midterm review. I'll show you the expectations for the exam, and we'll call it good. So if it's 9:30 and I'm still yammering on, please stop me, as usual when we do this stuff. Oh, I guess one other thing to talk about as well. I got some questions on Discord a day or two ago about presentations. I guess there was some uncertainty with that. I will send you a formal announcement with the date and expectations for that. You don't have to worry about it before the exam. It will be after the exam. Probably late next week would be my guess. So probably next week, Friday or something of that nature. Just as a status update, and it's low pressure, low stakes, just give me and everybody an update, and we'll do probably another one of those before the end time for the semester. But where I wanted to start with was your responses to the in-class assignment last time. Because if you have a requirements homework and you maybe are a little struggling with what a FR and NFR are, we should probably talk about it. So the first one here, these are no groups identified here. So functional requirements, let's start with those. Customers should be able to see what is available in store, what can be ordered, and what is in stock from other stores nearby. So customers should be able to products, have a separate login and update inventory, store information, and log hours. These are not bad requirements. They are a little bit nebulous in terms of specification, though, if that makes any sense. So like this first one here, this would honestly be three separate requirements to me. So there is too much information going on here. So if we break this up, customers should be able to see what is available in store. That's kind of, I mean, as a human being, and some of you may debate that, what is available in store is kind of ambiguous. What do you mean, what is available? Is it stock? Is it candy bars at the front for people to grab? Is it employees? Is it floor space, right? So it's, again, pretend like you're trying to teach, not teach, but specify something that maybe somebody who doesn't know anything about your application would need to know. Customers should be able to see the amount of products available in store, maybe. Web application that is accessible to both consumers and employees for an NFR. That's a good one. That's pretty clear, right? Needs to be able to load in mobile and desktop forms. Also good. Load on any device or screen size without any problems. Also good. So basically, these aren't too bad. Couple of nitpicks because that's what my job is here, is to give constructive criticism too. And again, forgot to contextualize this. I am acting as the person giving you feedback here. So anything I say will be constructive criticism. Okay, so you don't have to feel bad if I tell you that, okay, you have to go back and fix something, or this was good, this needs work. Okay, I'm trying to help you here without being negative, and that's going to be what I want you all to do to each other, that we all suck. No, you don't suck. That's these honestly, so these are pretty decent for a first try. I will say that. But no, some people don't take criticism very well. Um, and that's a human thing, right? Um, my goal is to get you all to be able to take criticism and give it properly, I guess. So if I'm telling you to fix something, it's not negative. It's that I see something good in here and I want it to be better, basically. And that's what you should all be feeling too. But no, never think that you all suck. You're all wonderful. The fact that you're all here is a credit to you and your classmates, honestly. So a couple of other things here too. So these should all have identifiers. I didn't obviously tell you that here. That's in your assignment. This should be NFR1. NFR2, NFR3. This should be FR1, FR2, FR3. You might have like FR 1.1, 1.2, depending on what you need to do, but should have IDs so that we can refer back to them later on, like a little lookup ID type of thing. Other point, if you looked at the assignment, you noticed I gave you a big spiel about a shell syntax. So that's a specific thing to requirements too. It's a formalism. So, oh, what should we do? Website shall load in mobile and desktop form. Needs to be able to is very informal. We're looking for formal technical writing here. So websites shall be accessible to both employees and customers. It's clear, it's succinct, you know exactly what's going on, right? Okay, so moving on. Not bad, honestly, not bad. This one here, we need to talk about too. So again, it was an in-class assignment with zero expectations, honestly. This one you need to actually have full sentences. So that's one of the key things that I see here. So non-functional inventory database or security. This is not, these are not requirements. These are objects or um, yeah, basically objects or things that you need to do. They're not requirements, right? This should be system shall have an inventory database in a structured format. System shall implement encryption and decryption algorithms. Okay, so if you're writing just nouns, that's not a requirement. I mean, obviously, I know what you're trying to do here, but the rest of your team will not know how to implement inventory database. What are the fields that you need? What structure? Is it SQL, no SQL? Are you doing a graph database, right? So it's these kinds of things we need to really specify. All right, functional. Search functions based on user input, storefront and purchasing options. Again, so we're getting away from sentences. These should be like a single sentence per requirement. Location service. So hopefully you all get the idea here. Don't just dash off a quick thing. Make sure that me or your teammates, as people who may not know what is in your head, could go ahead and do something based on what you're telling us. So storefront and purchasing options. System shall maintain a public storefront. Probably be more of a non-functional though. Um, Store shall provide purchasing options in the form of credit card, Bitcoin, PayPal, Amazon Pay, whatever you want to support, right? So just kind of, again, really think about what you actually need to be specifying to the user here. The concepts are there, right? So if you gave me this as an assignment, um, just again, constructive criticism here, you would lose points, but I would tell you what you need to do to fix this and how you could iterate it for the next version. So when you all give me your requirements, I'm going to tell you everything that's wrong with your requirements. And I want you all to not feel bad about it. Okay? It's going to be positive. When you go to submit the next version, they will be better, right? This is all about revising and iterating here. So again, ideas are there. This one, sorry, it's blurry. I had to screenshot it because Google did not want to copy and paste a table. So props for actually having a table there. So functional, non-functional. System must be able to support multiple customers online simultaneously at high speed. There's a lot to unpack with this one. So support multiple customers online simultaneously at high speed. So I assume this is referencing the performance requirement and accessibility, well, requirements that I had written down. So reading through this one, this would be more of a non-functional, okay, because it's related to performance. It's related to uptime and availability. So that's more of a touchy-feely global type of thing. And you might argue one way or the other. Some of these are arguable, I will say that. So if you can defend your point, okay, maybe it does make sense, but if you have to explain it, that means the requirement wasn't clear enough. But you do have a lot here, so you could honestly break this apart into multiples as well. I'm not going to go through all of them, but I'm kind of cherry picking requirements to talk about. So System shall support multiple customers simultaneously. That would be one, right? So you're providing a many user type of system. System shall be highly available with a response time of less than X milliseconds. So just kind of again tease these apart. Have really one impact or one statement per requirement. The system should authenticate employees logging into the system. That's a good one. Solid, right? You're not saying what authentication algorithm you're using. You're not saying if you need to use Kerberos, if you need to use the Windows Server, if you're using LDAP with Linux, that's up to the developer. So this one I like, right? It's vague enough. Vague's a bad word because I'm using that as a bad thing. Um, there is enough flexibility there that you can implement it however you want, but it's very crystal clear what the point is. So this is a good one here. Only employees can update the inventory. Makes sense. Um, what else do we have here? System must check user's device screen ratio and adapt accordingly. A little bit of vagueness here. So check the user's device screen ratio. Good. Adapt accordingly. What does that mean? Does it mean reorient portrait to landscape? Does it mean resize? That kind of, hopefully you can see the differences and ambiguity there. So this one, authenticate, that's a very clear idea. Adapt accordingly, too vague. Okay. So it's almost a touchy-feely kind of thing, and you may have a different opinion than I do, I suppose. But I will say this, so I think there was one more, I didn't drop it into these slides, but good first attempt. Overall, I'm looking forward to see what you get tonight with the assignment. Um, does anybody have any questions on what I'm looking for in terms of requirements? Because I kind of wanted to walk through these just so that maybe you know what my expectations are a little bit more than what I have written in the document. You'll probably have to write a requirement or two on the exam as well, so make sure that you are good with them. PogChamp is now a dinosaur. Okay. That may always have been a dinosaur. What other emotes do we have that are appropriate here? Are we all good with requirements though? Verbally written ones in or verbally written requirements? Yep. Okay, good. Again. The only reason I'm spending time here is that I know some people struggle with requirements at times, I hope. Key takeaways. Technical writing. So use active voice, meaning you are saying X does Y. Okay, so very clear, succinct writing. It's not because this and this and this, we are going to do this. That's a passive type of technical voice or writing voice. Be clear, be concise. Don't be friendly in your writing, right? It should be dry, drab, bland technical writing. That's the best kind for this type of activity. You are clear. Every single word has a purpose, basically. Okay, so if we're good with requirements, let's pop on to a little bit more of modeling here. And pro tip from your professor, do not search for modeling in Google Images live on camera because you get interesting results from Google Images when you do that. He said, having done it last year. Excuse me. So we ended up about here, right? So we were talking about the different types of UML diagrams. And again, we're not going to be using all of them. And I guess just to be clear for the exam, we are not going to have UML on the midterm, but we will talk about requirements on it, okay? So use cases, I don't think we're going to get to really today, so we're not going to worry about this for the exam. Final exam, you have to talk about it, but midterm, no. So here we had different types of diagrams, right? And we have a lot of different specific syntaxes that you have to follow depending on which diagram you want to use. The key distinction is the structural versus behavioral diagram. So structural is the static or non-changing aspects, right? It's how you build the thing typically. Behavioral will be sequences of activities, communication, messages, basically things that are going to be changing over time or behaviors you express. So static, dynamic, effectively. So structural we started talking about as well. Classes, standard class diagram, break apart your code base. You know, here's a class, here it's all its attributes, its methods, relationships, that kind of thing. Object diagrams, the instantiation of a class diagram. We'll be getting into these with some examples later on. But the behavioral side, this is where things start getting a little bit less rigid and they get a little bit more flexible. And these are where you're going to start speccing out what your system should be doing and how it can be doing that, I suppose. So the first one we're going to look at in the next lecture, which will be Friday, is use case diagrams. And these are ways that you can try to figure out what activities your system should be doing. This can be a very common approach for figuring out early on what your system is. And what you're going to do here is that you're going to pick a bunch of goals or use cases that have to be done. And then we're going to kind of collect them into a single use case diagram and figure out, okay, who are the entities that are dealing with these activities. So here's an example of a use case diagram in the top right here. I'm kind of covering up the authentication person, but that's fine for now. So this would be an online shopping system use case diagram. We can view items, make a purchase, complete our checkout, log in. Obviously, a ton more activities with online shopping, right? But who is involved? We have a customer. We have PayPal, credit card payment. This one is identity provider, and then my face is hiding authentication as a service. And what you're seeing here, it looks very simplistic, right? I mean, there's not a whole lot going on here in terms of difficulty, but view items, make purchase, complete checkout, log in. We're going to see these again later when we go from use case diagram to class diagram. So these basically become methods or functions for your classes. View items, make purchase, complete checkout, log in, log out. You can probably visualize those as function calls from a shopping system superclass or something of that nature, right? So you're just kind of trying to get high-level perspectives of your system, what it's doing, which entities interact with which classes, basically. So we'll be doing this, don't worry, you'll get some practice with that. Okay, we also are going to have interaction diagrams, and these are going to be further broken down into sequence or collaboration diagrams. And what these basically mean are that we're going to see messages being passed. And then you're going to ask, well, what is a message? And I'm going to say, well, a message is just something that is happening. So we're going from one particular state, we're sending a message. This message might be a data packet. It might be a flag saying it's time to start this sequence. Basically, we are just kind of moving through, you know, if we're thinking of a program like a state machine, we're kind of moving from state to state to state. Here are the messages, here are the activities that are triggering these things. And it's kind of focusing on, again, the actors or the entities that are dealing with the system plus the components. State charts, state diagrams are more high level, but there's a lot of similarities in some of these. So let's take a look here. So we have our use case diagram up here. slightly cocked line to separate it, just because that seemed like the best way. This here would be an interaction diagram, and it's a little bit of a different format than what you've seen before. So these little boxes on the top are going to be entities of some kind. They might be classes, they might be objects, might be actors. It just kind of depends on what you need. And then we have messages or transitions happening here. So this example is walking us through how phones work, at least how they used to work. So the caller is going to pick up their phone. It's going to be off the hook. That's going to send to the phone exchange, which sends you a dial tone. Caller is going to dial a number. Exchanger is going to set the ringtone for the receiver. That person takes it off the hook. You talk. You're done. Everybody puts their phone down, and we end the diagram. The way these are read are you start at the top left, and then you go down. So I'm starting here. I go down. I see this is my first line. Now I go this way. Here's my line. Go down. Follow the arrows. Go down. Go down. Come back. It's basically giving you that sequence of events. How does your application work? How does your project work? This is a very simplistic view. You can have much more complicated diagrams, and we'll be getting to that, don't worry. You can have things happening in parallel. You can have multiple messages going in multiple directions. Just depends what you need. All right. Yeah, so the other points here too. In the next lectures, we're going to be getting into some of what these models are, how you can build them, what the steps are we need to take to actually create them. But each of them will have a specific purpose. So use case diagram. Let's figure out what requirements we need, right? So you're probably going to do this before you do requirements in a general project. You're doing requirements first because I felt like that was a interesting way to get you started there. Again, depending on your process, you might do one first or the other first, or not at all. It just kind of depends. So if we're figuring out our high level requirements with the use case diagram, class diagram, and then an object diagram, which again we'll talk about later, let's figure out what objects we need in our system. What are the classes? What are their methods? What are some examples of instantiating this thing? If the example doesn't make sense, go back and fix the class diagram, which is probably tied to a use case diagram. Maybe you have a problem there. You're missing a use case. You're missing an entity. You're missing a relationship. And these are all related to each other. So if we have our requirements, we have our objects and their relationships. We have our phone doubling down on audio. Come on, go away, Bluetooth. Okay, thank you. Again, you can't hear that, but my headset's talking to me. Makes me look like I'm going insane. Okay, so objects and relationships, and then our scenarios. So here's an interaction diagram. You see a scenario playing out here, but we also see how things are related to each other and what the sequence of events will be. Then a couple of diagrams that we're not going to dig into in class, but are fun to talk about nonetheless. So here would be a state machine, or a state diagram. State flow diagram depends on your favorite way of describing it. Basically, how do you go from state to state to state of your program? Initial state, application is off. State 1, show the intro. State 2, show the main menu. State 3, gameplay loop, if you're doing a game. Or initial state, not accessed. State 1, homepage. State 2, user profile page. State 3, product listing. Just kind of depends on what you need, honestly. And what we see here are some arrows to follow again. We love our arrows. Love our little rectangles here. But on these lines are going to be the trigger for how you go from one state to another. Any of you ever do state diagrams before? Tend to get a handful of people that have. When I was an undergrad, we did state machine diagrams in it's like a languages class. So if you do you get into things like Lisp or Racket or Scheme, and you start talking about how to describe programming languages. Probably you're going to get into state diagrams, or I guess formal logic types of things. But what these basically do is it describes the common states of your system, and it tells you how to go from one state to the other. If we are sitting here, say at our main menu, so let's say state 2 is our main menu for our game or our phone app or whatever we have, we are never leaving the main menu until an event happens. And that event could be triggered by a user, could be automatically done, like maybe you have a timer, just depends. But this shows you the different, basically, states of your application. And if it's a continuous state, then you only have one state, really, right? You have main state. These are kind of helpful if you have applications where you can very clearly distinguish state 1, state 2, state 3, state 4, so on. If you're doing an embedded system, hardware off, booting up, load in configuration, initialize registers, right? So even, embedded applications could benefit from a state machine diagram. We also have our detailed implementation diagram, so component diagram, deployment diagram. We're not going to really be getting into these, but you can hopefully kind of get the gist from them. So component diagram, here's how different components of your system fit up or link up together. Again, we're not going to really talk about this too much, but we see staff components, we see safety inspection. We see that this is for some kind of a terminal. So I'm guessing it's going to be, I don't remember where I pulled this from. Just looking at my references here in my notes. Okay, nothing exciting. Sometimes I have the name for what these are in the URL. I put all the URLs in my little notes just in case they're needed by anybody later on. But components are basically level above class diagrams, kind of akin to a package diagram, honestly. You see the interfaces. You don't really need the implementation details of this thing, right? You don't need to know what a safety inspection is or staff or a map or a defect. We have some definition further down in another diagram. But we care about how they interact with each other. Okay, so you kind of see this little open circle, closed circle. These are linking up to form a coupling, basically. And this coupling is just an API interchange, right? Could be automated, could be manually performed. I assume staff and safety inspection here would be like a actual manual process, right? But you're describing the interfaces and the components, basically. We're not going to dig too deep into these. State diagrams would be nice to talk about. We're really going to focus on like use cases, interaction diagrams, things of that nature. Okie dokie, so that is actually it for the set of slides. Any questions at all? This would be another example of a use case diagram that we'll talk about next time. Next time being Friday. Okay. So then let's scoot over to the midterm. Make this a little bit bigger. Can I hide you? I can hide you, good. For some reason I remember not being able to hide this thing. Okay, so the way this is going to work, I've got an announcement started, so this will go out after class. And if you have any leftover questions too, office hours are at 10 on Blackboard. But Wednesday we will not have a class session. Okay, so that'll be an announcement, but there will be no stream, nothing on Wednesday. The intent would be that you would do the exam during the hour of class, but I know everybody's got crazy schedules this semester, and if you want to do it after a good night's sleep or something like that, you can do it later on. The exam will open at midnight on the 3rd. So basically at 12 o'clock the exam will open. So if you happen to be awake and you want to get it done, you can do that. And it will close at 11:59. So don't start it at like 11:30 p.m. and expect to be able to turn it in at 1:30. It will close at 11:59. So you have the entire day to get it done. If something crazy happens and you couldn't do it, I will review sob stories on that, but please try and get it done sooner rather than later so that you don't have to worry about technical issues. Current plan is that it will be either a Word document or a Blackboard timer. So there's no timer. It will be you have all day to do it. So you can start it at 9 and finish it at 5. Yes. So let me pop this into chat. Opens Wednesday at 12 a.m. and closes Wednesday at 11:59 p.m. You're the bomb.com. Thank you. Don't make me regret it. It's very flexible in your favor. Bomb.dom. Ooh, is that a new domain? Okay. I've got this little note here. Again, please read it carefully. Standard warning of zero tolerance for plagiarism and cheating. As much as I like you all, I won't hesitate to be the bad guy. So don't plagiarize, don't cheat, please. It makes everybody's life a living hell, mine included, and yours. Nobody likes it. Just don't do it. So, technical stuff out of the way. And I still haven't decided if I want to just leave it as a Word document or make it Blackboard fields. I haven't decided yet. If anybody has a preference, feel free to pop it in the chat. I think either are probably fine for you all. I guess let's start the session out. So now we have basically 20-ish minutes to chat, and this entire time's for exam review. I put this up last week, Word doc. Okay, I could see that. Then you have it at least offline, right? Which means I'm gonna have to significantly change it next year too. Does anybody have any big questions out of the review? Otherwise, I'll start cherry picking and ask questions. Normally, the way I would do this in a real classroom is I would read a question out and wait for somebody to answer it. And then I'd see 30 people rapidly scribbling down the answer because they didn't go through it before. But are there any big open questions from these list of questions that I've got out? Yeah, so requirements we will not, or models we're not going to have on here. So let me edit that really quickly. There it is. Can do it in Markdown pretty quickly. I probably could have just written that in HTML. Okay, no UML. Hide you. So looking at these questions, hopefully you can get a feeling for what I'm looking for in terms of your write-ups. So these are going to be short answer. You know, don't just give me a one-word answer unless it makes sense, but actually write a sentence, small paragraph, whatever you need to do to convince me of your perspective here. So like this question here, what are some considerations we'll have with project planning? So I'm asking you to create a project and you need to plan it out. What are some things that you're going to have to deal with? NFR and FR. Okay. So this is from the intro. So early on. Excuse me. So, good questions or good answers. So, Jake, yours. No, yours is fine, honestly. You're gonna have to deal with requirements at some point. So, you're gonna need a phase for requirements engineering. You're going to need to decide on a language, maybe not early on, but at some point you'll have to pick that. Which process model we're using? Absolutely. So, are you doing Agile? Are you doing Waterfall? Picking that early on gets everybody on board. Absolutely. And for a question like this, I'd be a little bit more clear too. So I'd say something like, describe 3 considerations, and then you'd say budgeting, and then you'd tell me what budgeting would entail. Right? So I will be clear on expectations, and if there's any ambiguity, it errs in your favor. But yeah, good ideas there. And hopefully you can kind of see too that with these questions, there's some flexibility. So if you have a consideration for project planning that's different from what I would expect, and you make a reasonable point, you would probably still get points for it. So do your best, read the questions, make sure that you at least make an attempt. All right, so here's a good one. When is considered best for a problem to be detected in software development or in a software project, and why? So let's say you discover something that is a show-stopping big problem. You're following a process. At what point would it be best for that bug to be discovered? Testing. Why testing? Planning phase. Okay, so I'm going to hold you both to the why. Early. Before launch. Okay, so I'm seeing... Yep, okay. So, good, because you can replan your project. Thank you. So that's kind of why I was hoping Jacqueline, it's okay, so Jacqueline did say it's not deployed yet. Okay, we'll have more time to try and fix the problem. Yeah, so remember that graph that we saw of the impact when problems are found. If you find it early on, you can really quickly resolve it, right? If you find it post-deployment, you have to do recalls, you have to go through processes again, you have more time to fix the problem, you can replan your project. So all good answers. Um, so finding it during testing, it's still good. Okay, I'm not going to discount that. So as long as you would have a good reason for testing, I would be okay with that. Ideal, I would say at the very early part of the project, but as long as it's before it gets in the customer's hands, um, it's probably an acceptable answer. Yeah, but probably not the best. Yeah, absolutely. But it depends on your process too, right? So if you're doing something a little bit more agile, you could be testing right in lockstep with requirements engineering. It just kind of depends. Again, this is the class of trade-offs in the class of um, figuring out how to set up a project. But best would hopefully be when we have enough flexibility to fix things. Okay, so we've got ethics. Hopefully nothing too crazy in here for you. Yeah, because you had all those ethics reflections you had to write. We talked about various forms of ethics, so hopefully nothing too crazy there. Um, Here's a good snarky one. What is software engineering? Aren't you all just programmers? Can't you just whip up my app idea and make me a millionaire? I like this one. Okay, here's a good one. Who are the stakeholders? We've been talking about them quite a bit. So who are our project stakeholders? Investors, customers, programmers. Anyone with interests in the project. Absolutely. Anybody who has an input or has a vested interest. Good job. Typically, when I ask this question and somebody hasn't been paying attention, I usually get somebody who has invested money or somebody who's bought stock in the company. But these are people who are a part of the project in some way. Yep. Developers, developers, developers. Maybe employers and customers too. Okay. Good, good. So again, I'm just kind of scrolling through looking for questions to call out, but if any of you have any that you're not clear on, doesn't make sense, I'm more than happy to chat about them for a couple minutes here. Hmm. I can probably guarantee a question like this will be on there because I want to see your thoughts on process models. It might not be V versus Agile, right? These are just kind of general constructs to base questions around. I guess you might see some of them verbatim, but I will tweak these a bit so that they're different. But not tweak in the, develop one, add 1 plus 1, and then the actual exam question is a linear algebra or some kind of Calc 3 level nonsense. All right, so here's one that we should probably talk about because we didn't talk about user stories really. I've mentioned it offhand. So this would not really be a fair question to throw on there, but does anybody know what a user story is based on maybe what you've gleaned from class? Let me do this really quickly too. I don't want to give you a question that we haven't talked about, and I missed that when I reviewed it earlier. Let's just go ahead and strike this one out for now. I mentioned that offhand. I know we've talked about it, but description of a product from a user. It is a segment or small project you work on in the major project. Yeah, so if you remember back to, I guess this would be a fair question because we talked about it with Agile. So this is an Agile thing, right? So this would be where you grab a card. Okay, I'm going to write my little story on it. I want to log into my system. I want to be able to buy a product from the website. And then I'd stick it on the board, and then I'm going to work on this today. So yeah, segments a small piece of a project, but they're not requirements. A specific anecdote. Yeah, so I like that one. It's just a small task. We could consider them to be like goals, but they are not as rigorously written as a requirement is. And if you're doing Agile, you still need to do requirements at some point because this is going to be necessary for your project. That's what else do we have here? The process models, hopefully you all kind of understand the key differences between them. We're lumping Agile as one kind of mass of processes, XP, Crystal, Kanban, Scrum. We're going to say they're all just Agile. So just kind of be aware of the key benefits and disadvantages of something like Agile at a high level. But any open questions on process models? I know we spent a lot of time on them. Make sure we're all good with that. So there would be some config management questions on there. So very important part of software engineering, even if you've never used Git or Subversion before, maybe you weren't expecting to use it in class. It is a massive part of any software engineering project. So whether you like Git, which you're again, being kind of forced to use a semester or you like another type, the ideas are kind of similar, right? So branching, why do we do that? Let's work on product lines. Let's work on experimental versions. Let's do a bug fix. Let's work separately, basically. Um, it's why we branch. And you can branch in pretty much any configuration management tool. Git is different, right? So how does Git differ from traditional config management systems? This is a good question. This is almost more of a system administration type of question, but we spent a little bit of time talking about it. So what makes Git special? And I guess keep in mind you have all of that nice extra fluff that you get with most config management, like tasks and project planning and all that, if you do a GitHub type of thing. Okay, so this is a good talking point. Local copies. Technically, in all traditional systems, you can have local copies. In Subversion or other ones, we could call that our sandbox. So it's the area for you to play in, make your changes. But you do have local copies in the other style too. Since we only have a couple minutes, I'll move this along. Git is distributed. Yeah, so there you go. That's where I'm looking for some of the more detail here for the answers. So local copies would be wrong. Um, Local repository would probably be closer to that. So again, Git, you do all of your configuration managed locally and then you push it to a remote. It is distributed. You have to commit before you push. Yeah. The standard ones you check out, make your changes, check back into the remote server. So standard, you have one server or multiple depending on if it's a load balanced, but there is one repository. Git, everybody has a local repository and we share a remote. So yeah, distributed versus centralized. Okay, other things here. So requirements, be able to write a functional, non-functional requirement, be able to describe the different types of NFRs, um, take a moment and think about why it's probably the hardest part of the entire process, and un understand. Okay, so yeah, these are not going to be on there. Basically understand the requirements engineering process. So we spent some time talking about requirements elicitation, right? How do we figure out which requirements we need? How do we get them from our users, from our teams, all that fun stuff. So a live update these for you. Look at that, trimming out questions live on camera. Since we have 1 minute left, any remaining questions? Again, this is shouldn't take you more than the standard class time just because I'm giving you the whole day. That's just to avoid any technical difficulties. It's not a 24-hour exam. It's a 1 hour exam that's flexible for you all. So, any last minute questions? Otherwise, I have to pop over to Blackboard for office hours. And that's my reminder in 10 minutes office hour starts. See you Friday. Thank you. Okay, I will say this. Good luck, everybody. Don't stress out. I don't write my exams to punish you. I write them to make sure that you're all keeping up. So it should not be a stressful exam. At least I don't intend them to be. So good luck and open note. Yep. So I'm not looking over your shoulder. So open book, open notes. If you are taking information from the internet, do not copy and paste it. Distill it. Cite your source if you've, taken a big chunk from somewhere. But yeah, no plagiarism. Yep. Think of it like a take-home exam, I guess, might be the best way to describe it. Before the internet was a thing. All right, you as well. See you Friday, everybody. Good luck.